let's talk about some max and min word problems. So here are some word problems that we can solve with the quadratic function. The reason why these are so specific is because inside of them we're looking to find either a maximum or a minimum, or sometimes they say the largest or the smallest. And when we are asked to find anything with a max or a min, it means that we need to know the vertex. So that's why these word problems go along with what we're doing. Let's take a look. We're going to do a few word problems together. So the first one is, if two numbers have a difference of 10, what is the minimal possible value for their product? Okay, so it's always nice if we can start with some let statements. So let's let x equal one number. And let's let y equal the other number. So we know then x minus y equals 10 because they have a difference of 10. So there's one of my equations. My other thing that it's asking is a minimal possible value for their product. Of course, we know the word product means to multiply, which means I want to multiply x times y to get my minimal product. Well, we have a little bit of a problem here. I have x times y, which are two different variables, and it's hard for me to figure out. So this is my function, f of x equals x times y. It's hard for me to figure this out because I have two different variables going on, but I can go back to my original equation, which said x minus y equals 10. So if x minus y equals 10, let me bring that negative y over to the other side, and that tells me that x equals 10 plus y. X equals 10 plus y. And if x is equal to 10 plus y, that means I can go back to my equation, and wherever there is an x, I can substitute in this 10 plus y. Okay, so I'm looking for the minimal, so that's minimum. So I need my vertex. I have my equation, okay? So my equation of x plus y or x plus y times y. And notice this is factored form. So since it's in factored form, I'm going to take this set of brackets and put it equal to 0 and solve for y. So I get y equals negative 10. And I put this bracket equal to 0, and I still get y equals 0. I'm going to find the midpoint between those two. Oops. Sorry about that. I'm going to find the midpoint between those two. So negative 10 plus 0 divided by 2, which is negative 10 over 2, which equals negative 5. So this is the x coordinate of my vertex. To figure out the y coordinate of my vertex, I'm going to put that negative 10 back in. So I get 10 plus negative 5 times negative 5. And that's going to give me 10 plus a negative 5 is 5 times negative 5, which equals negative 25. Okay, so here's my vertex, negative 5 comma negative 25. And what this means, since we were talking about 10 plus y equals 0 and y equals 0, this represents my y number. And this represents the minimum value of the product. So if y equals negative 5, that's one of my numbers, x has to be my other number. Well, x was equal to 10 plus y, or 10 plus a negative 5, which is 5. So my two numbers must be 5 and negative 5. Okay, so we came up with our original equation, which was x minus y equals 10. And then we came up with our second equation for our product, which was just x times y. Realizing we can only have one variable in our equation, we rearranged our top equation to give us x equals 10 plus y and substituted that in. That gave us the equation of 10 plus y times y. From there, we found our vertex, and since it was in factored form already, we went with finding our two zeros and then finding the midpoint. That gave us the x-coordinate of our vertex. Subbed it in, we got our y-coordinate of the vertex, and then realized, okay, so that x-coordinate of the vertex was actually our y number, which is negative 5. And then the negative 25 was the minimum value of the product. And so we took that y value of negative 5 and put it back into our original equation to find the x number, which gave us 5. So our two numbers are 5 and negative 5. All right, a rectangular field is bounded on one side by a river and 3 other sides, totaling 80 meters of fencing. So here's my river, and here's my fencing, okay? And we always assume that it's opposite sides are equal. So here's a width, here's a width, here's a length. So I know that the 3 sides total 80 meters of fencing. So that means that's my perimeter. My perimeter of 2 W's plus an L has to equal out to that 80 meters of fencing. We want to find the dimensions of the largest possible lot. So the largest possible lot is our area, the largest area. And we know area is equal to length times width. Okay, so same problem as before. I have 2 different variables in my equation. I want only one variable, so I'm going to go back to my perimeter equation. I'm going back to this equation, and I want to rearrange it so that it equals L equals or W equals. So I think it'd be easier if we did L equals, so I can just subtract 2W from each side. So L is equal to 80 minus 2W. And if I have that, then I can take that and replace it to wherever there's an L. So 80 minus 2W times W. Okay. Notice now we have just the W in the equation. No more 2 variables. We're back down to 1 variable. In order to solve this, I'm looking for the largest possible lot, which means the largest possible area, which means a maximum. So I need my vertex. Again, notice this is already in factored form, so I can take each one of these and set it equal to 0. Bring that 80 over, becomes negative 80. Divide each side by negative 2. W equals 40. I can take this W, set it equal to 0, and I just get W equals 0. And then, of course, I find the midpoint between my 2 zeros, which is going to give me 20. So we have just figured out that we have a width of 20. If I take that 20 and I put it back into my area formula, I get 80 minus 2 times 20 times 20. 80 minus 2 times 20 is 80 minus 40, which is 40 times 20, which is 800. So that's my max area, is 800 meters squared. So this is what I have. I have 20 and 800. This 20 represents my width, and this represents my area. But I need my total dimension. So let's go back up to our diagram. If this is 20, and this is 20, and I know from my perimeter that I had 80 meters of fencing, then I can find my length by going 80 minus 2 times 20, 2 times my width. 80 minus 2 times 20 is going to give me 40. So my dimensions then, just to finish this off, my dimensions of the largest possible lot are going to be 20 meters by 40 meters. Okay, so same as before, we had to come up with two equations. Once we had those two equations, it was just a matter of finding my zeros, taking the midpoint, and then subbing it back in. If they had asked us what the actual area of the largest possible lot would be, then we would have said 800 meters squared. Okay, let's keep going. Application number 3. The cost of a ticket to a hockey arena seating 800 people is $30. At this price, every ticket is sold. A survey indicates that if the price is increased, attendance will fall by 100 people for every $5 of increase. What ticket price will result in the greatest revenue? There's greatest revenue. And what is that revenue? So when we talk about revenue, what we're talking about is the ticket price times by the number of tickets sold. Okay, it's always by whatever you're selling, how many you're selling, by how much it costs. Okay, so let's talk about price. The price right now is $30, but they want to increase the price by $5 for every person that attends. So it was $30, but it could increase by $5 more than once. So we're not sure how many times they're going to increase that price. So we can put in X there. Okay, so they might increase it by $5. It might increase it by $10. It might increase it by $15. We're not quite sure, so we're going to put an X there. Same thing with number of tickets. We know that they sell 800 tickets, but if they increase the price, the ticket sales are going to fall by 100 people. So 100 people. But we don't know how much they're going to up this ticket price, so we don't know how many hundreds of people won't go. So again, we can put an X there to show that we're not quite sure. Notice the money and the money end up in the same bracket. This is like our money bracket. So this is our price, and this is the items sold. So these are the tickets. Okay, we want to know the greatest revenue, and of course, greatest revenue is your maximum revenue, which means we need to know our vertex. And lucky for us, it's still written in factored form. And so I'm going to take each one of these factors and set them equal to 0 and solve. So subtract 30, 5x equals negative 30, divide by 5, divide by 5, x equals negative 6. And then over here, I can take that 800 minus 100x, put that equal to 0. I'm going to subtract 800, I get negative 100x equals negative 800. Divide by negative 100, divide by negative 100, x equals 8. Okay, but now I need the midpoint between these two. So negative 6 plus 8 divided by 2, which is 2 over 2, which equals 1. So that just equals 1. So that means they're only going to up the price by $5 one time. So if I go back to my price, 30 times 5 times 1, this means my new price is going to end up at $35. And if I go to my ticket sales, 800 minus 100 times 1, that's going to be 800 minus 100, which is 700. So they're going to sell 700 tickets, and it's going to cost $35 for each ticket. Let's go and see what the question is. And then if I multiply that, I get my revenue, right? Because that's what revenue was equal to. And that's a big number. Let me see, I need my calculator for a minute. And I have 700 times 35, which is $24,500. So that is our revenue that we would be bringing in. Wow, lots of money. Okay, but let's go see what the question actually asked. What ticket price will result in the greatest revenue, and what is that revenue? So the ticket price, of course, is $35. So the ticket price equals $35. And the revenue, we just figured that out, would be equal to $24,500. So always make sure that you go back to your question and you take a look to make sure that you are answering it exactly what they're asking for. Okay, we don't want to miss any parts. They were asking for two things there in that question. What's the ticket price and what is that revenue? Okay. All right, just one more example. And this is when you could be given an equation. So this is nice because we don't have to come up with an equation of our own. It's already given to us. A ball is kicked into the air, follows a path of h of t equals negative 4.9 t squared plus 8t plus 1.4, where t is the time in seconds and h is the height in meters above the ground. Determine the max height of the ball to the nearest tenth of the meter. So we're looking for max height, which means we need to know our vertex. Well, if you look at this, this is lovely. It's in standard form, which means we know our x-coordinate of the vertex is negative b over 2a. And if I look at my equation, I can see that I have a b of 8, so it's going to be negative 8 over 2 times negative 4.9. So it's going to be negative 8 over 9.8, negative 9.8, double negative. And then I'm just going to actually go ahead and divide these. Because we have decimals in our equation, that certainly means that we can have decimal answers. So 8 divided by 9.8 equals 0.82, if we round properly. Okay. So 0.82, that would represent our time, how long it takes to get to the maximum height. So that's 0.82 seconds. But I need my y value. So I'm going to go back to my equation, and I'm going to find h of 0.82. So I just need my equation here. Negative 4.9 times 0.82 squared plus 8 times 0.82 plus 1.4. Okay, so let's see here. We got 0.82, and we're going to square that. So, and then I'm going to multiply that by a negative 4.9. And this gives me negative 3.29476. I'm just going to keep my decimal places for a minute. And then 8 times 0.82, which is 6.56, plus 1.4. Okay, so let's add those all up. So I'm going to start with negative 3.29476 plus 6.56 plus 1.4 equals 4.66524. But of course, let's round that to one decimal place, let's say, which is 4.7 meters. So my vertex is at 0.82 comma 4.7. And remember, we're talking about like a football being kicked. So it looks kind of like this. This is our parabola. So this is the max that we're hitting here at 0.82 comma 4.7. This represents height, and this represents time. So it took 0.82 seconds to reach the maximum height of 4.7 meters. Okay, let's go back to our question though and see what we were actually being asked. Determine the max height of the ball to the nearest tenth of a meter. So the max height of the ball is 4.7 meters. Awesome. Okay, and I think that brings me to the end. So there's some homework. You can definitely go into page 31 and you can try all these questions. They're there for you to try. There's also an assignment. So that's where I'd actually like you to start. Now the assignment has 8 questions on it and kind of 2 of each kind. So if you're having any struggles, go back to this video, rewatch the video to give yourself some ideas and hints on how to do that assignment. Otherwise, there's homework once you're done to keep you busy. Thanks, and I hope you have a great day.